Alright, today we're going to look at the unit circle and how we can use this to help us solve some trigonometry type questions. So the first thing is, when you look at the unit circle, it looks quite confusing, but what we're going to do is we're going to break it up into sections and figure out patterns and so on from there. So first off, the reason why we call it a unit circle is the equation for a circle is x squared plus y squared equals r squared, where r is the radius of a circle, and then xy is just a coordinate on that circle. So for any circle, it doesn't matter what it is, if we had, say, a radius of 5, that means whatever that coordinate would be, whatever that xy coordinate is, x squared plus y squared would equal 5 squared. So with unit circles, we make it even one step easier. We say the radius of a unit circle is always 1, and then our formula modifies to be x squared plus y squared equals 1 squared, or just x squared plus y squared equals 1. So from that, we can figure out missing coordinates. So if we know that this coordinate, negative 4/5 y, is on the unit circle, that means using our equation, x squared plus y squared equals 1, we just have to plug it in. So we'd have negative 4/5 for our x coordinate. So to get y, all we'd have to do is go 1 minus, and negative 4/5 squared would be 16 over 25. So that means y squared would be 9 over 25. And when we square root both sides, we get y equals 3/5. So we know it has to be 3/5, but because we're squaring, and we also know from grade 11 in Math 20, we know the CAST rule, we get two matching possible locations. So usually they're going to give us the quadrant. So in this case, if we're dealing with quadrant 2, that means we'd have a negative x, which we do, negative 4/5, and a positive y, which we just calculated is 3/5. So we don't have to worry about changing the sign on it. So let's do another one. Letter B is the same thing, except it's 3/10. So we'd have 3/10 squared plus y squared equals 1. 3/10 squared is 9 over 100. So if we subtract 1 minus 9 over 100 would be 91 over 100. And from there, we can just square root both sides. Square root of 91 doesn't really simplify, so we'll just leave it as that. And square root of 100, we can write it as just 10. So now in quadrant 4, we should have positive x and a negative y. So because it's a negative y, we just add a negative on to our answer, and we're done with that one. Okay, letter C, same kind of thing, but it's decimals. So it's just asking, is it on the unit circle? So if it is, if we put it into the equation where we square both sides, so 0.65 squared plus negative 0.76 squared, we just have to see if that's equal to 1. So on your calculator, just type that in, 0.65 squared plus 0.76 squared. That does equal 1. So we'd say yes, it is on the unit circle. So we can try it again with square roots. So same thing, root 7 over 2 squared plus negative 1/7 squared. We just see if that's 1. Root 7 squared would be 7. 2 squared is 4. And we would add on 1 over 49. So 7/4 plus 1/49 gives us like 1.77 or something like that. So we'd say, no, it's not on the unit circle. So it's a pretty easy formula to find missing points or to determine whether something's on the unit circle or not. One other neat trick with the unit circle is because we have, if we remember, if our angle's in radians and we have a radius, we multiply those two together, we can get the arc length of the curve. But if our radius is 1, we'd have angle times 1, which then is just the angle. So that means if our angle's in radians, our arc length of that curve will be the exact same number in centimeters or whatever our units are for that question. Now what we're going to do is we're going to tie this, how this fits in with the unit circle. So our unit circle is just basically a bunch of special locations around the circle. So the first thing we want to do is think of our main location. So at 0 degrees or 0 radians, our circle would have a radius of 1. So that means our coordinate would be 1, 0. If we went up to 90 degrees or pi by 2 radians, our coordinate would be at 0, 1. And if we keep going, 180 or pi, we'd have negative 1, 0, and our 270 degrees or 3 pi by 2, we'd be at 0, negative 1. And then when we get back to 0 again, which would be 360 or 2 pi, and it just keeps repeating. So our four main x and y axis locations, the coordinates are just going to be 1 and 0 in various locations, and then positive or negative. So the rest of our unit circle now are angles in between. So what we want to do is, for Math 20-1, we basically had three special triangles. We had a 30-degree triangle, a 60, and a 45. So we memorized those three, and that helped us figure out certain sides of the triangle. So in Math 20, we used 1, 2, and root 3 for the 30 and 60 triangle. We used 1, 1, and root 2 for our 45-degree triangle. Then from there, we just used the cast rule to help us figure out positive and negatives. What we're going to do differently for the unit circle is we're going to take those same triangles, but now we're going to make it so that our radius is 1. So if you look here, we've got our 45-degree triangle, and we see we got a 1, 1, and a radius of root 2. So what we want to do is change that to a 1. So we just have to divide both sides by root 2. So that triangle would become a 1, and then 1 over root 2 and 1 over root 2 on both sides. The other two, we do the same thing, but we want to make this a 1, so we're going to have to divide by 2. So we'd have root 3 over 2 and 1/2. Same thing with the other one, it'd be 1/2 and root 3 over 2. So those are the coordinates that we're going to use for a unit circle because we want that length of the hypotenuse to equal 1. So what that means now is if we draw a 45-degree triangle, so you can see in this bottom, we've got our unit circle. Our angle is 45 degrees or pi by 4. So we went over 1 over root 2, up 1 over root 2, so our coordinate would be 1 over root 2 in the x direction, 1 over root 2 for our y direction. So that is our values that we use on the unit circle. Same thing if we do a 60 degree. So 60 degree, we'd have 1 over for the x, root 3 over 2 for the y. So what happens now in terms of a unit circle is it just repeats. So actually let's go back to the title page so you can see some of the patterns on here. So you can see that when we have 30 degrees or pi by 6, we get root 3 over 2 and 1/2. If we went over to the quadrant 2, 30 degrees up, which would be 150, we get the exact same coordinates except the x is negative because we're going backwards. If we do 210, which is pi by 3 past 180, pi by 6 past 180, we get the same coordinates again, but they're both negative. And then once again in quadrant 4, we get the same. So you can see all of the 30s give us the exact same ratios except the positive and negative straight. If we look at the red ones, the 45-degree ones, you can see they're all the same as well, but positive and negative. And for 60, same thing again, positive, negative. And you can see 30 and 60 are the same numbers, just reversed, because a 30-60 triangle is kind of the same. Just depending on your reference point, one is opposite over hypotenuse for one side. Okay, so if we look at this 30 and 60, here we'd have half on this side and root 3 over 2. So you can see the cosine of 60 would be 1/2 adjacent over hypotenuse. But if we do the sine of 30, it's opposite over hypotenuse, so that would be the exact same answer. So we get 30 and 60s kind of matched, they're just flipped. 45 is a little bit different, and away you go. One other thing to notice, if you look at the 45 one here, they've got it written as negative root 2 over 2, where we said it was 1 over root 2. Those are the same thing because all they did is they rationalized the denominator. So if we times both top and bottom by root 2, that would give us root 2 over 2, which then is the same thing again. So you might see it our textbook tends to use 1 over root 2, other sources write it as root 2 over 2, but those are both the identical answer. Okay, so now let's go back to where we left off here. So we're going to look at finding exact angles. So they want the exact coordinates using these as radians. So pi by 2, remember, is 90 degrees. So we know that coordinate then would be 0 and 1. 2 pi is all the way around, so that would be at 1, 0. 2 pi by 3. So 2 pi by 3 is going to be, pi by 3 is 60 degrees. So 2 pi by 3 would be 60 degrees over there, which would be 120. But anyway, we're dealing with radians, so 2 pi by 3 is a 60. So our exact coordinates then would be for a 60-degree angle triangle. We're going to go negative in the x direction. So we'd have negative a half and then positive root 3 over 2 for the y direction. 5 pi by 4 would be 45 degrees past the 180. So 45 is 1 over root 2 for both. But because we're going to be in that quadrant, we're going to have negative x and y direction. And our last one, negative pi by 4, would be 45 degrees going backwards there. So they should be the same coordinates. And then just check your quadrants. So in that quadrant 4, we got a positive x, but a negative 1. So add on the negative, and we're good. So you can use the unit circle to help you figure these out, or what I usually do is just use our special triangles, our 30, 45, and 60, and then figure out positives and negatives based on the quadrant. So here's another one, same kind of thing, but backwards. We're trying to figure out where the angle is. So negative 1 and 0 would be there, so that's our 180, or pi in radians. Root 3 over 2 and 1/2, that would be our 30. That would be our 30-degree angle triangle. So that would be 30 degrees or pi by 6. Here we got negative 1 over 2 and positive, so that's 45 degrees up like that. So that would be 135 degrees, or in terms of pi by 4s, that would be 3 pi by 4. And our last one is negative 1/2 and negative root 3, so that would be down here in 60 degrees. So that would be a 180 plus 60 would be 240 degrees, or as pi by 3, that would be 4/3, so 4 pi by 3. Remember, you can always convert these just by dividing by 180 if you need to get the fraction out of it. So all I did to figure those out, in case you're wondering how I did them so easily, I just basically remembered our triangle, so our 30-degree triangle. Our sine was 1/2, cosine was root 3 over 2. So you can see that matched that one, so that's why it was 30 degrees. Our 45-degree triangle, we had 1 over root 2 for both. So that had to match that one, except the negative meant it was in quadrant 2. So I went 180 minus the 45 to get 135. And our last one was a 60-degree triangle, because for that one our cosine is 1/2 and our sine is root 3 over 2. And once again, because they're both negative, that would be in quadrant 3. So I went 180 plus the 60 degrees to get the 240. Okay, arc length works the same way. Remember, arc length of a circle is the same as long as it's in radians. So if you have a pi by 2 angle, that means we'd have pi by 2 arc length in meters, centimeters, whatever the unit is. So all you basically need to do is figure out what the angle is in radians. So 225 would be the same thing as 45 degrees past 180. So if you convert that to radians, that's 5 pi by 4. And our arc length then is 5 pi by 4. And the last one, we got a coordinate negative root 3 over 2 and 1/2. So that would be in this quadrant here. And those ratios are for 30 degrees. So that's pi by 6. So that means we're in that location. We're at 5 pi by 6. So that would be our arc length for that one. And that's it. So we're finished with that. So unit circle, like I said, if you want to use it, we went through it in class. We labeled it all to kind of figure out the patterns. But really, remember, all we basically need to do is remember our 3 special triangles and use that along with our grid to figure out the locations and whether they're positive or negative. And we're good. That's all.